One of these days I'll get the hang of this recording. Let's see here. Testing, 1, 2, 3. Okay, now it's working. Yeah. You can raise your hand if you're ready. You ready? Okay. Easy, huh? 20 ohms. Yeah. 20 ohms. Okay. So you guys already did this one?
Well, I did have back here, but I'm redoing it.
Now all these problems I assigned, the answers are in the back of the book so that you guys can, when you're at home, you can make sure that you understand them. And that's the way I typically do homework. Because I want you guys to know if you don't get the right answer at home, you can keep working it. You understand how to get it?
I didn't get it with the KV. I don't think I got it with the Ohm's law.
Let's go ahead and use KVL to work on it right now.
That's what I'm doing over here.
Because you don't have to use KVL for these, but when we actually start doing ones that you have to use KVL, you don't want to learn KVL on those problems. Because those will be much harder for you to learn KVL on. There's a temptation on these to simply combine all the resistors together and kind of cheat. But it's not going to serve you well on future problems if you do that. It's going to actually prevent you from being able to continue on and learn. This is your chance. You have about 5 minutes to ask me questions if you're struggling with the problem. That's what this time is used for. So if you have any struggles, raise your hand and I'll help you out.
Just on this problem?
Just on this problem. If you can't do it.
Another problem, I'm having problems with it.
Okay. We'll get to all. We're going to work all the problems. We're going to get all the problems. Are you done?
Yeah.
Okay. Plus V. See, in this case, you want to know V, right?
Well, I asked you to do amperage and voltage,
Find V and R.
or V and R.
Yeah. So in this case,
Oh, they wanted the R for this.
yeah, you have two knowns, and you want to know this voltage, so you can have one unknown variable and solve if you have the other two variables. So in this case, all you have to do is say minus 60 plus V plus 40. And then that'll give you the unknown variable. So you don't really have to do I. I mean, you could do that and then solve for I and then get that. So either way.
Okay.
But if you're not given this, assume you're not given that, or that. You could still solve this equation for V even without I or R. So.
Okay.
I guess I don't know how to do it this way, but I just maybe I derived that the regular formulas.
The way you do it is you go, actually I'll just show you on the
60.
60 plus V plus 40
And you just do the
equals
voltage
0.
first, and then you do the resistance second. Is that what the deal is?
Well, it's asking for V and R.
Okay.
Yeah, once you find V,
That's what I knew you doing. Okay.
yeah.
I just looked at it. I just see it the other way.
Yeah.
Okay.
Any more people have any questions for me before I give you the solution? If you're having struggles with the problem?
Two different ways.
Let's see, is that it? Minus 60 plus V plus 40 equals 0. Oh, you got it? Oh, yeah, 20 ohms, okay. Okay, let me give you the solution to 4.23. Now, sometimes in these problems, you're actually given too much information. In this one, you're really not, because you're being asked two questions. But in order to solve the very first part of it, you're given too much information. So, the question says find V and R. So for the very first part of the problem, you don't really need to know R, you don't really need to know I. In fact, we know what we're going to do is we're going to write an equation that says this voltage plus that voltage equals 0, because that's KVL, right? So what do we really need? We only need voltages. We already know all the voltages except for one. The way math works is if you have one unknown variable and you have everything else in that equation is known, then you can solve for the unknown variable. So when you do this problem, just think to yourself, I can have one unknown variable. That's the most I can have. Everything else has to be known. If it isn't, you can go ahead and write the equation. Then you may be able to use Ohm's law, or you may be able to use another equation to solve for but in this case, it's going to be simple. Just go ahead and write KVL, and then you can evaluate the problem. So we start at the bottom left corner is what I usually do, or at the negative terminal of the battery. Go through the voltage source, and you see the negative sign first. So you put negative 60 volts to start off with your KVL equation. And then you come through here. You don't really need to know the amps. It's not going to bother you. You're going to hit plus V. You continue to go around, you hit plus 40. You continue to go around until you get to this point, and then you say equals to 0. In this case, you only have one unknown variable. Everything else is known. So you can rearrange the equation and solve for the unknown variable. So in that case, we can leave the V over here. We can move everything else to the other side. When we move everything else to the other side, the sign has to change. So you wind up with V equals 60 minus 40. V equals 20, right? 20 volts. Okay. And then it says find R. So R, the second part of the question, this would be the A part, I guess you could say, and then this would be the B part of the question. R is equal to, what does Ohm's law say? R is equal to V over I. Now the question is, do we know V and do we know I? And we do. We know I and we know V. So really, you could have solved this R part of the problem even without knowing this up here. You don't even need to know that. So this is going to be 40 over 2. It's going to be what? 20 ohms. And put a square around your solution. 23. Okay. $25. Okay, you got a 20 kilo ohm resistor. This says VX. You have a 10 kilo ohm resistor, 8 volt battery, and this says I, and you have a 40 kilo ohm resistor there. And it says find I and V. So since we're in the KVL section, this is the section of the book that's talk about Kirchhoff's voltage law. So we're going to use KVL on all these problems. So you don't really have to. Sometimes when you're given a problem, you have to kind of ask yourself, okay, what am I going to use to solve this problem? In this case, we already know for all these problems we're going to use KVL. So it kind of makes the starting of the problem simple. We're going to use KVL on all of them. So start here. Go through the voltage source. You're wanting to know what is Vx, right? I think I may have called it Vx. I don't know what the book calls it. V. I call it Vx because you may think V is like the units on the back of it, so I use Vx. Okay, to distinguish it from, this V. I don't want someone to get confused with that V because that's just the units. So minus Vx. Okay, I come to this resistor and I have a problem. What's the problem?
Don't know the polarity.
Don't know the polarity. So I'm going to assign a polarity. Okay? What polarity am I going to use?
Positive on the left, negative on the right.
Positive on the left? Yeah. Well, in this case, we're saying I is going this direction.
Right.
Which I know is actually wrong because the current's coming this way. But in this case, it doesn't really matter. What did I do here? Okay. What I did on this problem, I put just plus over here, so let's just do that. Doesn't matter. I know this is going to be messed up because, first off, the current's going this way, but in the homework, he says the current's going to go that way. So we already know it's not really going to be right. So this is not really, if the current is flowing this way, like the question says, then the voltage drop will be in this direction. But even though we know that's not going to be right. But since it is indicated as this direction, we're going to use the passive sign convention to make it work out. Does everyone understand that? Okay. Your I, what you're saying I is, needs to match up with this in order to use the passive sign convention. Otherwise, all your voltages here are going to wind up being backwards. Okay. And for this one, if we're assuming I is flowing this way, then the voltage drop across that resistor would be as indicated there on the screen, on the board. So now that we have a reference voltage, we can complete KVL. We go through this resistor. We get plus what? What's the voltage drop across that resistor? We don't know it, but we can say that it's equal to I times 10K, right? Okay. I times 10K. We go through this. What do we assign? We're going through the plus, right? So it goes plus 8. We continue to go through here. We hit a plus sign and we say plus. What's the voltage across this? I don't know, but I know that whatever it is, it has to be I times R. I times 40K. So it's I times 40K. And then I continue to go around and I wind up at the same point I started. So I say equals to 0. Now what can I do? I can rearrange these terms. Right?
So you didn't even put 20K up there.
Do what?
You just put Vx, you didn't put the 20K.
20K. Oh, yeah, that's because it says find Vx, find I. I'm just using KVL. I could replace this with I times this, right?
Okay.
If I do that, then I wind up with only i's being unknown, okay? So yeah, I can say Vx. My problem with this is that I have two variables that are unknown, so I need to write an equation for the unknown variable. In this case, I can write the equation for Vx. What is Vx going to be equal to? This says I is coming through here and that I is going up through here. So I'm calling this I. And this is saying that, what does Ohm's law say?
I times
V is equal to, Ohm's law says that in a resistor, the voltage drop, the magnitude of the voltage drop is I times R, and that the sign of the voltage is always in a direction that tends to cause a voltage drop across the resistor as the current passes through it. Correct?
Right.
So the magnitude of the voltage in Ohm's law says that Vx is going to be what? I times 20K. But what is the sign of the voltage in this case? Is this correct? Is this the passive sign convention? No, it's not the passive sign. If you use Ohm's law on a problem that is not using the passive sign convention, what does the book say? What did we review the other day? You have to put a minus sign here. Because we know that with this reference current and this reference voltage across the resistor, it's not using the passive sign convention. So you have to add a minus when you use Ohm's law. If you use the passive sign convention, if your reference voltages and currents are passive, then you use a plus for Ohm's law. If it's not, then you use a minus. So Vx is equal to minus I times 20K. Now we take this and we substitute in for that. We get minus I times 20K plus I times 10K plus 8 plus I times 40K equals 0. So really we have the same thing we had before. We just substitute the Vx for that part of the equation. The first minus came from the fact that we went through the source this way and we saw a minus. The second minus comes from the fact that whoever did this problem did not use the passive sign convention when they did it. So if you follow the rules, you'll always get the right answer. But you have to strictly follow the rules. So minus and a minus gives you a plus. So you get I times 20K plus I times 10K plus 8 plus I times 40K equals 0. Only thing we did there was what? Combine the minuses together. Everything else is the same. Now what can we do with the problem? Well, we can take the 8 and we can move it to the other side of the equation. If we do that, what happens? Becomes minus 8. I'm just going to erase it because I'm sick of writing. That's the easy way to do it. Move it over, it's minus.
There you go.
That's the advantage of having a board here that we can erase. Now group the i's together. Right? I, you got a 20K plus 10K plus 40K equals minus 8. So I is going to be equal to what?
70.
Minus 8 over,
7.
yeah, well that was sloppy. Minus 8 over 70K equals a weird number of minus 0.11 milliamps. So in the end, we wound up with a minus anyway. With all those minuses and stuff, we wind up with a minus, which tells us what?
Not passive.
That the current's actually flowing this direction. But see, this is still the correct reference because the minus here tells us that the actual current is flowing in the opposite direction that our arrow is actually pointing. So your reference has no bearing on what is actually flowing. Just like on the road, when you drive your car, you know the reference direction on the right side of the road is to go right-handed driving. We're not in Europe. But that doesn't mean you have to drive that way. It's just the reference direction. Okay? The same way with this current. This is only a reference, so you can do the problem. So we know that in this case, I is minus And for 2,000 years, we've known about minus numbers, so it's really not that big of a deal, right? People used to have a big problem with minuses thousands of years ago. They didn't think they really existed or made sense. It was a huge breakthrough in math to actually realize that, yeah, you can have a minus number. You can have money and you can owe someone money. But it took them a really long time to get over the fact that really minus numbers don't make any sense. But they really do make sense. And it's a huge breakthrough in understanding to realize that, yeah, minus numbers make sense. You can have something flowing one way and you can have something flowing the opposite direction. Because I know some people in the class have problems with minus numbers. But yeah, minus numbers do make sense and they have value.
But in this case, it just tells you that they assigned the wrong direction at the beginning.
Yeah, which is totally feasible. You could do that in a circuit analysis problem. You can assign the wrong direction not knowing what direction the current is. The whole purpose of doing the problem is you don't know what the answer is, right? If you already knew the answer before you started to solve it, then why solve it?
Would it come out different if they'd assigned different polarity to the resistor?
You can assign this current in a different direction. You can assign all these in a different direction. If you follow the rules, you're going to get the same answer.
So if we switch so he assigned the polarity of the resistor based upon the reference of the current that he chose.
No. Whoever did this problem, their current and this did not match.
So that confuses.
Well, we're starting with a simple problem where you know which direction the current is, but just imagine that this problem had a bunch of current sources in here and you didn't actually know what direction the current was flowing.
So why would he have assigned that polarity to the?
Because these are going to get more complicated. When we start talking about Kirchhoff's current law, there could be a branch off here, and even though this current's flowing this way, this current could have been flowing this way if you had branches down through here.
So are we assuming that he assigned the voltage across the resistor based upon a measurement?
He could have assigned it based on a display. Like perhaps this is a display. I mean, it's perfectly feasible that this could be a voltmeter and this is displaying the value of the voltage. And that just happens to be fixed. And it's also feasible, but this could be a problem where the current could change. It could go positive or minus. And like in a real industrial application, you can make a motor go forward or backwards. So you can change the direction of the current.
I guess what I'm asking is the polarity of the 20K ohm resistor. Are we assuming that that's based upon a reality, an actual? That is true. That's not just
Well, no, it could be a reference. For example, let's say that you have this voltmeter. You have the red lead connected here, and you have the black lead connected here. What that means is you've assigned a reference polarity of this being plus and minus, because if this value turns out to be plus, then you know what direction the voltage is. If it turns out to be minus, you also know that direction. So that assigns the reference for that. Another thing that's perfectly feasible is that this could be a variable voltage where the current could flip back and forth. In that case, the current could change back and forth.
being that there are two arbitrarily determined polarities there, I could make the polarity come out any way I wanted to just by what I assign.
Okay, well, let's solve for Vx and see what we get. And once we make a specific value, we'll see how that affects everything. Vx is going to be what? Well, actually, we already wrote this equation.
Yeah, minus.
Vx is minus I times 20k. So now that we know what I is, let's plug it in. We found that it's minus 0.11 milliamps. Okay, Vx equals minus 0.11 milliamps, okay, times 20K. So what does that give us?
2.28 volts.
The millis cancel, and with the K, milli and the K cancel. And then that gives us what? Two point 2.2, a plus 2.2 volts. So in this case, what that means is in this case, this voltmeter here would read 2, and there would be a plus out here. And that would be a decimal point.
So, I'm just trying to put this together. So you say the reference across VA simply is indicating how you hooked up the voltmeter.
Your voltmeter, yep. Yep. Now if I took this, assuming this is a variable voltage source, if I took this voltage and changed it to minus 8 volts, then I would get a minus 2.2 volts here. Yeah. But in this case, it's plus 8. That one was, the difficult thing about that one was that you had the minus numbers in there, and someone didn't use the passive sign convention. They paid the price, but they didn't really know, we're assuming they didn't know what the current was. 25, 27. Did you guys get through all of them? Let's see here. 11. Okay, so we got to 1140. Okay. So the next one says find IX. Find IX. So what I'd like to see right now is for you guys to get out a blank piece of paper, completely blank, and draw this problem really big, just like I'm drawing it, on your page so I can help you. And even if you've worked it before, I want to see you work it again because I want to see if there's any problems that I can help you with. This one's fairly easy compared to the one that we just worked, so. The first thing I really want to see is I want to see Kirchhoff's voltage law, the equation, written out. You know, what is the very first equation that you come up with? Because the entire solution is going to be based on that first equation that you write down. you get the first equation, raise your hand so I can check it. Sorry. Okay. Plus 10. Yeah. Yeah, that's right. So it's 10, it's 6, 20, minus 10 plus 40. Well, where does that one end? Okay, and then that's going to be 40i.
No.
40i. Yeah. Yeah, that's right. Then you just group the voltages together, and then the other one's on the other side. Let's see. IX. Where'd you get? Let's see. Where'd you get the IX from? Yeah, but we're summing voltages. We're going around here and we're adding up all the voltages. So, yeah. There's 1, 2, 3, 4, 5, 6 voltages. So you're going to have an equation with 6 voltages plus 6 voltages, and then set those equal to 0. I know. Yeah. 1, 2, 3, 4, 5, 6. Right. You got 6 voltages, so you're going to write down 6 things here. Equals to 0. You start here, right? You need to assign your polarities. None of these have polarity, so you have to go ahead and put your plus and minus everywhere. First step. You know the large terminal is plus, and the small terminal is minus. So go ahead and put your plus and minus through here. That's the first step. Yeah. And on your resistors as well. And you can assign a reference direction. The book says I is flowing that way, so put I there. Minus, let's see here, right, yeah. So you got minus 12. Now we're summing voltages, okay? We're not summing currents, we're not summing resistors, we're summing voltages. So anything you have here has to be a voltage. Is 10 ohms a voltage? How do you make an ohms a voltage? In order for an ohms to become a voltage, you have to multiply it times the current. V equals I times R, right? Ohm's law says voltage equals current times resistance. So in order to transform a resistance into a voltage, you have to multiply it by I. And in this case, you know I is flowing this direction, right? The book says 4.27. See there, IX? So IX in this case is going to be your unknown variable that you're going to find. So it's going to be, this is going to be 10 ix. 10 ix. Yeah. Actually, you're going to have to just redo it right here. Minus 12 plus 10 ix. See, by multiplying by I, you've transformed it into a voltage. And then plus that. And then plus what? No. This is a voltage already, so you don't have to multiply it times ix. So just scratch out the ix. Yeah, that's good. And then plus what? 20 times ix.
20 times IX.
Same as this one, 20 ix. 20 ix and 10 ix and 10 times ix is the same thing. So 20 ix. And then you hit this one, there's a minus 10. Right? No, that's 10 volts. You don't have to multiply times ix.
Exactly.
Yeah. And then, but this is a minus, you hit. If you look here, see the current, your current's going this way, right? So if you use the passive sign convention, you would make this plus and this minus. So you should hit the plus side first. So you want this to be plus. That plus, and then this all gets set equal to 0. Did you get it? Minus 12 plus 10i plus 6 plus 20i minus 10 plus 40ix.
Cross that one out.
Oh, this is the one. Okay. Okay, good. Minus
Got that basic
12
equation
plus
you're looking for.
10i plus 6 plus 20 minus 10 plus 40. Yeah.
Now, does it give me a negative number? Because I got negative 16 over 70, but I got a negative number. Now, would you multiply that by a negative 1 to get it?
I didn't get a negative number.
See, how'd you not get a negative number? So I started here, right? Negative 12, okay, plus 6, minus 10. It's negative 16
Well, see,
on the voltages.
minus 12 plus 10ix. So you're summing, you're adding resistors. The way you're summing voltages, not.
Right, I separated them. Here's my resistance.
Yeah, but this is your first equation. Everything's based on your first equation. This first equation's not right. So everything's going to be wrong if the first one's not right. So we have to start here. So the answer,
Negative.
yeah, minus.
Yeah, so this is a minus 12,
Uh-huh.
okay?
This is 10 times I.
I times 10, oh, not K this time.
Yeah.
Okay.
Plus 6 plus 20 times I. So in order to transfer that to a voltage, you have to multiply times I. Minus 10 plus 40 times I. That equals 0. And then you solve that equation. And matter of fact, I don't know how you got that. If you didn't have the I's in there.
No, I didn't have the others. But it's still
Okay.
sum of voltages over sum of resistors.
So now use that equation and group the terms together, and then you can solve it.
All of that.
You gotta add all these, right, how Mr. Austin?
Yeah, I'm
Huh?
summing.
You add all your voltages.
Uh-huh.
I didn't know.
Minus 12.
Said they were daylight, but they were
Put minus 12 right there.
60 watt, but they were just right at 60 watt.
Now you have to assign reference
Oh, yeah,
voltages.
Gotcha.
Now this says Ix is assuming the current's flowing this way.
absolutely.
So assign your voltages across your resistors, assuming passive sign convention. Do that first, then I'll come back.
All right,
You see what I'm saying?
Yes,
Go
sir.
ahead and I want you to see. I want to see a plus and a minus across these
Right.
resistors,
right.
and then I'll come back and check it.
Okay, sum them all up, and then once you replace that with 0, then it becomes a positive number.
Yeah. Once you move these over.
Yeah, I moved them to this side, once you add
It's
them up,
not-
you have to change the sign, so this
Yeah.
becomes positive, that becomes positive, that becomes negative, you have 16.
No, not 16. Well, this 16?
This one's, yeah, that's 16. And then once you group these, then it just becomes
Oh,
16 or 70,
yeah.
and you have positive numbers.
Yeah.
Guys,
Sometimes 60
Screw that.
That's it right there.
Minus 12 plus 10 plus 6 plus 20 minus 10 plus, what is this? 40
Which
times
one?
I? Oh, that's 40 times I.
40.
Okay. Good. Did you get it? Your first one. Okay. Well, we're out of time, but I'll give you the answers. So how you do this problem? You do minus 12, and then you have to assign a convention, a passive sign convention across it. The book says that Ix is assumed to be this direction. So for passive sign convention, you would do a plus and then a minus because the current flows through it. There's a voltage drop. Plus, minus, plus, minus. The very first thing you always do is you put a plus, minus across your resistors. Okay? That's the first thing you do. And then now I have the minus 12 plus 10 Ix, okay, plus 6, as I go through this one, plus 20 Ix, minus 10, plus 40 Ix. I get back to the same point that I started. I set it equal to 0. I group all the terms over. I wind up with Ix. I'm going to do two things at once. I'm going to group the Ix's together, and I'm also going to separate the numbers out. 10 plus 20 plus 40 equals, now I'm going to move the voltages onto the other side and change the sign. That's going to give me 12 minus 6 plus 10. What does that give me? It gives me Ix equals, what's this voltage? 16 over, what are all these added together? 70. Gives you 0.229. Okay. Now, did you guys finish 29 and 31? Okay. Well, what we're going to do for next class is we're going to do read section 4.5 and 4.6.
Already up there.
That's already up there. Okay. Read 4.5 and 4.6 and do let's see. We're going to do 33 through 45 odd. 33.
Sorry.
Okay, 33 through 45 odd. And here's going to be the solutions to the last homework that you guys just worked on.
Thank you.
So if you don't understand the homework, go through this and make sure you understand it.
Thank you, sir.
And after lunch, when you get back at 1 o'clock, bring your lab manual. Make sure you have your lab manual. In fact, every single lab for the rest of the semester, we need your lab manual.
Actually, I still have that last from last week. The one you printed out for us.
Mhm.
That's still the same thing we're working on?
Well, we're going to go to the next section, actually.
This one.
Yeah.
Campus 3 basic simulation.
No, we're going to do the DC class today. That's digital. That's for the digital class.
You just mind to copy off some? That's what I was doing.
Do what?
Need mine to copy off one.
Do you need any more?
No, I'm saying if he needs one, I can let you copy it like you did the other day.
Oh, no, I don't even know if he doesn't have it yet. He was thinking about digital class.
Oh, okay.
We have the DC class today. All righty.
All right.
294.31.
What's that?
4.29 and 4.31 are different from the other ones I've worked, but I'm not sure that I can figure it out from just having these points are all of a sudden thrown in here. We've got to figure across.
I'll go over them next class period.
Okay.
The first thing.
Okay.
9 volts of sources in series. Is that the one we're doing today?
No, we're going to do 10 and 11.
Yeah, I gotta get 15.